and know how to do everything already. Then the yellow ones are like stuff that holds more marks in your exams. So you see a lot of them is in like the right side one. It's all the last few topics. So all those you need to get them right. You need to get your foundation right. You know how to do. Then the red color ones are the ones that people might find like more difficult, harder to like understand and go through. So it's like these two topics. The first one, problems in real world context. Y'all all got see before in your exams, right? It's like super big question, and it's like it can be from any topic. It could be a lot of different topics mixed together, and it's like a lot of different parts. So if you don't know how to do one part, then the next part is like gone. And then the probability is like sometimes it's very hard to understand the question. Sometimes you don't know how to apply the concepts to the question, stuff like that. Then we can go through our notes. Then lastly for today, we are going through angles, triangles, polygon, then congruence, similarity, and mensuration. So these topics, we chose them because they are all quite like formula based. We don't need to learn a lot of content, but it's a lot of formulas you need to remember, and all these little things you need to know. Okay, so we just go through quick one. Okay, acute angle, obtuse angle, reflex angle, straight angle, complementary angles, that's like add up to 90 degrees, supplementary add up to 180, and straight to 90. Then all your angle property, this one you must know. You cannot like try to memorize it like 1 week before the exam. This is you need to know like right now. You need to know already. Okay, all the angles, adjacent angles on the straight line, all these like reasonings you all need to memorize also. Angles at a point, vertically opposite angles, these two are equal, corresponding angles equal. Alternate angles, the Z thing, and interior angles add up to 180. So they are supplementary angles. Okay. Then the triangles also, this one quite simple. It's like since like sec 1 or something. The equilateral triangles, all angles 60 degrees, isosceles triangle. So sometimes you all will need to use a lot of the base angles of isosceles triangle, those reasonings. Then your right angle triangle with the 90 degrees and your exterior angles of triangle. Okay. Then I'll just let you read through a little bit and then we can start with the first section. So this one is quite simple. It's all just testing your reasoning, how well you know them. Okay. Remember to write all your reasoning out. What angle, what parallel, what. Those are very important. You have to remember if this is time exam condition. If you don't know how to do one part, just skip. Because this one is okay, it's kind of linked, but the ones that are not linked, you just try to write some working down. And you can always refer back to the notes that you did. Okay, hopefully you are mostly done. I'll just start with the explanation now. So the first one, calculate BCD. So this one you all use the parallel lines, right? So it's either corresponding angles, vertically opposite angles, not vertically, corresponding interior alternate angles. So this one, if you can see over here, right? BCD is corresponding with FBD. BCD corresponding with FBD. So corresponding angles are equal. So over here, angle BCD equals angle FBD equals to 44 degrees. Then your reasoning has to add also corresponding angles. Then you have to add the parallel lines. ABC parallel to F. Okay. You all need me to slow down this here. Like raise your hand or something. Okay, then the second part, ABD. If you all see here, right, ABD is actually Sorry, let's continue. If you see ABB, this one, right? ABB, and then which parallel lines is this? ABB can do BDC. So you know that ABD equals to BDC. Then your reasoning is alternate angles. And the parallel lines will be AB and BC. AB parallel BC. Okay, but you want to find out BDC, right? So you use another pair of alternate angles. This one. So this one you got CBD already. So you know this is 26. Then you can use adjacent angles from a straight line. So you see okay. Angle FDB. FDB equals to angle DBC. 56 degrees, right? Alternate angles. And parallel to BC. Then you want to find BDC. So A, BED goes to BDC. 180 degrees minus 44 degrees. So here 180 minus 44 minus 56. Then you get 80 degrees. Then this one, you also have to remember to add your reasoning. It's a bit messy. Adjacent. Then the third part, AFE. Then AFE is this one. So this quadrilateral here is not trapezium, right? If you all went to done it until part C, it's actually not parallel lines. AF and BD are not parallel lines. So this one can't be a trapezium. So you cannot like answer the question as it is a trapezium. So you have to answer it as it is a quadrilateral, which is you have to take the sum of all the angles of the quadrilateral, 360 degrees, right? Then you minus all the other angles inside to find AFB. Okay. So you do 360. Angle AFB equals 360 degrees and 101 degrees. Then just now you found FBB already. FBB is 56 degrees. And then after that, the third part you found AFB. AFB is 80 degrees. And then you'll get 1, 2, 3. And then you have to write your reasoning. Angle sum or quadrilateral then A, B, D, F. Okay. Okay, then after that, you just need to do the last one. State showing your reason whether AF is parallel to BB. So if you want to find whether two lines have parallel, you have to use the reasoning. It's either they have alternate angles, corresponding angles, or inferior angles. Okay, so over here we are using inferior angles. If AF is parallel to BD, right, then their interior angle should add up to 180 degrees. It should be supplementary. So we have to see, okay, just now we found AFB. Okay, and we also know what is FBB. FBB is 56 degrees, AFB is 103 degrees. So if we add it up, right, 56 degrees plus 103 degrees. 179 degrees. It's actually not 180. So over here, you have to write AF is not parallel to BD because angle AFB plus angle FBB is not equals to 180 degrees. Just like that. Then you're showing them, you know what reasons you're supposed to use, you know the concept of parallel lines. It's quite straightforward. Everyone okay, right? You all understand? You all need time to copy. Yeah, done. Then we can just go straight to polygons. This one is actually don't really need to memorize, right? So you have your formulas. Sum of interior angles is n minus 2 sides times 180 degrees. Then exterior angle, 360 degrees. Then if you have regular polygons, you just take the sum divided by the number of sides. If you have exterior angle also divided by the number of sides. Then this next question, quite simple. Part A is quite simple, then part B is just a little bit of, give you a few minutes to do. Just try to apply the formulas you see on the top of the page to the question. Give you a little bit more. You can, I will start now. So for part A is very straightforward. Interior angle of 20-sided polygon. So you just use this one. Regular. You have to remember, it has to be regular. So you just apply this formula. Interior equals to 20 minus 2 times 180 degrees over 20. Then you get 162 degrees. It's super straightforward. This one is a 送分. It's just for you to get the mark. And then part B. This one is a little bit harder. You need to get your algebra right. You have to know how to do algebra. So n-sided polygon has 4 interior angles. So n-sided polygon, 4 interior angles. They tell you 4 of them out of n is 120 degrees. Then all remaining interior angles all measure 2 each. So over here, you need to find the total, the sum of the interior angles. This one. To get P, right, because we have however many P plus 4 interior angles measuring 120 degrees to get the total sum of the interior angles. So, like what I said just now, you write down in mathematical terms, 4 times 120 degrees plus the remaining interior angles is n minus 4. Okay, multiplied by 2, because all of them are all 2 degrees. 2 degrees equal to the total sum of the interior angles. So you have n minus 2 times 180 degrees. Just like that. Then after that is for just use algebra. 480 degrees plus n minus 4 degrees equals to, then this one you expand it, 180 n minus 360. Then after that, you just continue. Okay, n minus 4 p equals to 180 n minus 8 or 8. Then after that, you can just get your p ready. Quite straightforward. Okay, you don't need the degrees, because in the question they ask you to have p only. So p equals 180 n minus 840 over n minus 4. Just like that. Give you a bit of time to copy it. So over here you see that actually you see 4 interior angles measuring 120 degrees. You know you have to use either this one or this one already. Then they tell you remaining interior angles, all p each. So you know you have to use remaining interior angles plus however many interior angles, you have to use this formula. Okay. We go to another one. This one is a little bit more confusing. I just try. Give you like 30 more seconds. Yeah, I'll start now. This one actually seems like quite a few of you find it relatively simple. They give you a diagram also, so it's very easy to visualize what's going on. So find the number of sides in the second regular polygon. So this one is the second polygon, right? Then after that, this one, instead of using the interior angles, you have to use this one. Okay, so over here they tell you ABC is 108. And you know what, regular polygons all have the same angle, interior angle. So you know this is 108 also. Then after that, you find this one. So you have to apply, okay, you have to apply both interior and exterior. So you get 108 and you find angle FDE. Angle FDE. Let's do 360 degrees. This one just angles at a point, very simple. 360 minus 96 minus 108 degrees. Then write your reasoning angles at a point. Then you get 150 degrees. Over here, okay, after that, okay, you look back at your formula, right? You see, this one is very simple. If there are 360 degrees over n, the number of sides equals to the exterior angle. Or you could use this also, but this is more complicated. So when you do the question, we will choose to use the 360 degrees over n. So you find the exterior angle just over here. So this one, 180 degrees. Here and go. 180 degrees minus 156 degrees. 24 degrees. Then you know 24 degrees equals to 360 degrees over number of sides. So number of sides equals 360 degrees over 20 degrees. Then you get 50. Actually, it's quite straightforward, but you have to understand first. This is really just formula, but also it can be quite hard to visualize because a lot of questions they give you, let's say 2 triangles, but they're in different orientations. So it's very hard for you to visualize what the which triangle is congruent or whatever like that. So for congruent triangles, right, you all got 4 reasonings. It's either 3 sides are the same, or side angle side. 2 sides and the angle in the middle. or angle side angle. Two equal angle and one side. Okay. And then this one is right angle triangle only. You have to have hypotenuse that's the same, one side that's the same, and then it has to be right angle. So over here you can tell, right, like to find out if they are both congruent, you use three. It's either three sides, two sides with one angle, or one side with two angles. So it's quite easy to remember. You just think of it as 3, 2, 1. Okay. Then after that, similar triangles. This one is a bit less. It's either the two angles are equal. So if two angles are equal, then three angles are equal. Or the corresponding sides all have the same ratio. So AB, AB, ooh, AB, DE, AB over DE equals to BC over EF equals to, yeah. Then the last one is side same ratio and the angle in between equal. This is kind of similar to the congruent one. Then after that, the similar figures, this one is very simple. It's just you take the sides, right? The corresponding sides, the ratio, like AB over DE, then you square it for the area, or if you want a volume, you cube it. Okay. So now we try this one. We got some bubble tea for you all. You can just bring if you want. But have to focus. Okay. If you're ready, I'll just start. So the first one is like just now, the parallel line, ABN, line angle ABN, and you can tell angle ABN is actually this D. That's the alternate angle. These two angles are alternate angles. Then what else you know is this is 97, and this is one straight line, right? So you can find this angle, and then using the parallel line with alternate angles, you can find AB. Okay, this one quite simple one. So, angle ABN equals angle BFC, and right alternate angles AB parallel to BC. Okay. And it goes to 180 degrees minus 27 degrees. Or the other way you can do it is interior angles. Here, because there are two parallel lines. You can 180 minus 27 straight away. And then you get 1 full 83 degrees. Then the second one. Show triangle BCF and EDF are similar. Alright, over here is good because they tell you the two triangles that are similar. So you just need to show. So BCF. What I like to do, right, is I like to have BCF and EDF, this three. Then later on when you were doing the question, there's another similar triangle, right? Which is so when you draw it like that, it's a lot clearer which are the three triangles we're trying to look out for. And then if you want it even clearer, you can circle the corresponding points like BCF and EDF. The C and the D is the corresponding point C and D. So you know this line, this longer line, and this is corresponding, and then this line, okay, and this one is corresponding. Okay. So for this part, right, because they didn't give you the length. So you know the only reasoning you can use is the angles. Then okay. And this one you need to make use of your parallel lines. Okay, so for this one, parallel lines here and here. So you have this and this alternate angles. And then another pair of alternate angles. This and this. Or you can use vertically opposite angles. This two. Okay. Over here, B. The angle CBF equals angle FBB. BCB parallel. And after that, okay, let's say we use vertically opposite angle. Angle BFB equals angle BFB. Vertically opposite angles. Remember to write all your reasoning. Then after that, and these two triangles are similar. You can also write the angle similarity. Then the next part, show another triangle similar to this. So over here, you also use the angle similarity. Then this one you can do parallel lines. Okay, then you see corresponding angles. So you know these two angles are the same. Then after that, they share one angle, this angle. So since they have two same angles, right? You know that this triangle and this triangle are similar. Then you just need to write another triangle that's similar. Okay, EFB and EBA are similar. So triangle EBA. Okay. Then after that, over here, right? Since you highlighted, it's very clear already. Okay. Then they say ratio AD to DE. AD to DE is 3 to 2. So in total is 5. AE is 5. Then when you write down like that, right, you can see it's quite clear. What's the ratio of the corresponding sides? 3 to 2 and 5. And because this is a parallelogram, right? So you know the sides are equal, opposite sides are equal. So this is 3 also. So if you want to find the ratio of this triangle to this triangle, it's just 3 to 2. And then over here, 5 to 2. So ratio AB to CF. Okay. You know ratio, okay. Ratio AB to DE is 3 to 2. And that means, right, CF over BF is 3 to 2. Then you also know here AB to DF, AB over DF is 5 to 2. So you want AB over DF. Take this one divided by this. So 5 over 2 divided 3 over 2, you get 5 over 2. And then over there, just now you need to do a lot of calculations. So when you see this figure, right, it's actually quite clear. You have this 3, this 3, this is 5. So you know straight away already, this is 5 to 3. And you don't need to do a lot of calculations. And the next one, this one is just the formula you need to use. Given that this area, this is 9.72. Then we need to find the total area of the whole shape. And because they are all triangles that are similar, right? You know you can just add up the areas of these three triangles. But because this is not a triangle, this one you need to do the whole triangle. You just need to take this plus this. Or you can do this plus this plus this, and you minus this again. Okay. Then right over here. So you know, or the BAE triangle BAE over area of equals. Just now we find out the ratio, 5/2. Then you square it because this is area. If it's volume, then cubic. So we know that this area of triangle BAE over 9.72 equals to 5/4. Then the area will be 60.75. So cm squared. Then after that, the other area, this one. This one also the same thing. Can write more straightforward. Area of triangle ECF over 9.72 equals to 3/2 squared, which is 9/1. So area of ECF equals 21.87. So you can add up these two. Then you get the total. Total area equals this one 60.75 plus this one 21.87. You get 82162. So you have to make a lot of use of the diagram they give you. It's like super important. And you can bring, like what I like to use is highlighter. So I will just highlight the shapes. And then it's very clear. You can tell which are the triangles that are congruent, that are similar. Then you can go on to the yes. A, B to CF, is it?
Yeah, how you get that 5?
Oh, okay. So you see over here, right? I label here. They tell you area. AD is this one, right? To DE. This is 3 to 2. So you have this one big triangle and this one small triangle. These two are similar triangles. Okay. So they share this one side. So you know this is 3 to 2. Then what you do, right? You can add these two together. If you add these two together, you get the total length. This one. Then you know this is 5 and this is 2. So this big triangle and this small triangle, the ratio, right, of the corresponding set is this 5 and this 2. 5 parts and 2 parts. Yeah. Then after that, you know this is 3 parts because this is a parallelogram. They have the equal sides, right? So these 3 parts and this is 3 parts. And then this one corresponds to this one. That's why I circled. See, I circled the. You circle this one corresponding point. These 3 points correspond to each other. So this longer line and this longer line on the top triangle and the longer line on the short triangle correspond to each other and correspond to this one. So this is 3 parts, 2 parts, total 5 parts. Then this one, since these 2 are equal, so this is 3 parts. So you know this is 3 to 2, and this one is 5 to 2. Okay. Oh, this feels quite confusing. Maybe I can go through it with you later after the class. Okay. Then this next question is like real world context lah. What they love to give, right? And it's quite direct lah. So you can do it, right? Just be, yeah, right. Let's try to apply the volume. In 2 pages before, volume of one over volume of the other is the ratio of the corresponding height. Okay, this one. The corresponding, oops. You look at your paper, right? It's the corresponding height and then you cube it. So you try to form some kind of equation. I'll go through now. So for this one, I tell you, this one, the bottles are geometrically similar. Then the height is 18.4. Then they want you to find out what is this. Okay. So at first, the first step, let this be something. Let H CM be the height of 25 ml bottle. So now I label this as H already, 18.4 and H. And then I apply the formula we have. So the volume ratio, 75 over 2 equals to the corresponding side ratio, H over 18.4. And you cube it because it is volume. Okay. Then from here, you can either cube or you just cube root. So H equals to H over 18.4 equals to cube root 25 over 2. Then from here on is quite direct. H equals to this times 18.4. Then you get 12.3. Then after that, 3s. Then you write your final answer. Height of 75 ml bottle is equals to 12.3 cm. Quite direct. Can you move on? The next one, mensuration. This one is like all formulas, like actually. Your very basic one, the rectangle, square, triangle. This one is like given in your formula sheet, right? But just because it's given in your formula sheet doesn't mean you can just go remember. Because you imagine how many like seconds you can say that you need. You just flip through the formula sheet, you might as well just remember it. Then all these very basic one. And all these, you can look through them. You all should have gone through income already. Then all these volume ones. This one is a bit more complicated, but you just memorize it to be fine. Then after that, your circles, your outline, sector area, and area of segment. And then your conversion. Okay. So right, I know we got a lot of questions for this part, but we skip to the last question. So the one you all try more real world context, okay? So this one they give you a river. But overall, it's still relatively easy to understand. Like they even give you a diagram. So you all just try this one. Let's try the first and second part first. Then I go through, then you can try the third part. This one, right, needs you to know the properties of circles. So if you all don't remember, try to like do it. Like I just give you a hint. It's angles at the center equals to 2 angles at circumference. Okay, try to work it out from there. Okay, I'll just start now. It's okay if y'all like never finish the question. Okay, so this kind of question, y'all realize like actually you need to know a lot of different topics. Because this is actually under mensuration, but then you need circle properties, you need like triangles. Okay, so over here, actually this part is not even real world. It's just like one diagram for you already. And show that with this side is 6.73. And then this one you also know is the radius of the circle. For the circle you take that. And then this is center O, so A is the radius. Okay. So right, just now I told y'all can use this one property. Angles at center equals to 2 angles at circumference. So okay, over here, right, they give you these two. So you know you have to use like one of them. And I told you it's an angle, so it's probably this one. So there's two ways you can do it. You can either take this and then you relate it to this. So this will be 2 times 2.3, or you can minus first. You get the other side one. Then after that you get this angle. They are both okay. I'll just use this one. I'll use this one. Okay. So you find reflex. Reflex AOC equals 4.6 radians. Y angle at center equals to angle at then why do you want to find out this angle? Because over here, right, you can actually make a right angle triangle. Actually, you can don't make also, you can use the time rule, but the most straightforward one is you use the right angle triangle. So here is the right angle. Then you divide into 2. Then this is another circle property, right? It bisects the chord, the angle, the line from the center bisects the chord. So this is 5 meters and another 5 meters. So over here, you have this angle already. This is 4.6 radians. You can find this angle, which is angles at a point. So angle, okay, let's say this is K. Angle AOK. You take this one, 360 degrees, 2 pi. Total 2 pi radian. Then you minus this reflex angle, you get this 2. Minus 4.6 radians. Then you divide 2. So this splits up into 2. Then you get pi minus 2.3 radians. Okay. Then once you find this, right, you can use your rules. Your right angle, the Picasso. Okay. You have the angle here. You want to find hypotenuse. And then you got the opposite side. So if you have angle, opposite side, hypotenuse, then it's sine. Okay. So sine pi minus 2.3 goes to opposite over hypotenuse. Opposite over OA. Okay. Then OA is 5 over sine pi minus 2.3. Then you get 6.703. So it's quite confusing, but how to start the question is, you know you are given these two values, 10 meters, 2.3 radians. And with the 10 meters, you can't really find anything out. So you try to start with 2.3 radians. Then you see what property of the circle can you use to find any other angle. So over here, because this is, they only give you the center of the circle. So it's probably angle at center equals to 2 angle at circumference. Then you can find this one. And to see it faces the same direction, the angles. You don't use this one. Yeah. You don't use this one, then after that you find this one. This one will be double of this one. Okay, and so face the same direction. Okay. Then after that, we go down to the next part. Length of arc ABC. This one is like super direct. Okay. You got your AO already, and O is the center. So you just need to find use the formula, right? Then ABC goes to radius theta. Radius theta is 6.703 from here times theta. Okay. ABC, the theta is this one, right? So it's actually this one. You have your 2 pi minus 4.6. Okay. 2 pi. Then you'll get 11.3. meters. Then the last part, we are like a bit short on time, so I'll just go through a bit with you all. So this one, right, they give you the front view, cross section ABC. Okay. Then they tell you the volume of rain flowing down, 100 meter stretch. So they actually want you to visualize something like that. Okay. Like that. Then this is your cross. This one is this one. After this, it's 100 meters. 100 meters. If you have artistic talent like me, you can draw in your exam. But if you don't have, you try to visualize in your brain. Okay. Then over here, because this is 100 meters, right? What they want you to, okay, volume of rain flowing down, 100 meter stretch is 1,700 meters cubed. So if the rain, they want you to determine if the rain overflows. So they are basically asking you, is 1,700 more or less than the volume of this river? And you know, if you have this one, right, how do you find the volume? You take this one times 100 times this whole length of the river. So 100 volume equals 100 meters times the cross sectional area, which is this one. Then this one, how do you find? You use your formula. You flip back a few pages. This formula. Area of segment. So it's half r squared theta minus half r squared sine theta. And you just write it down over here. Okay. 100 times r squared 6.703 squared times theta. Okay, just now over here, right? Can simplify. You calculate out is 1.684. Okay. So half r squared theta, 1.684 minus half r squared sine theta. Half r squared again, sine theta. So this whole thing, right? This whole thing is your cross sectional area. Okay, this equation is a bit long, so you can calculate your cross sectional area first, then you find your volume. Okay, then after that, you calculate finish already. You actually get 1,551 meters. This is your volume. So does the river overflow? Yeah, it does. Because the volume of rain is more than the volume of the river. So yes, rain will overflow. Yes, rain will overflow and cause flooding. And you can see this question is 5 marks. So if you don't have like your foundations right, you don't know how to do the whole question, it's like 5 marks gone. Yeah, you all need to copy finish already. And the last thing for today. So right, I'm just going to go through the O-level paper. You have 80 marks for your first paper, 100 marks for your second paper, then you realize that actually they have the same weightage. So your first paper actually has a bit higher weightage than your second paper. So you have to be more careful. The first paper is usually slightly shorter question, a bit simpler, but you can make a lot of careless mistakes. So you have to be very careful about those. But you just keep checking and checking. And then another thing is 1.5 minutes per mark. You can use this to gauge your practices. Let's say you have a 10-mark question, 15 minutes. Okay. Then for E-Math or for any subject, but for math specifically, it's very important for you all to build a solid foundation. You have to know what you learn, right? You have to finish, you memorize all the formula, you actually understand the content first. Then after that, you can start with practice questions. If you memorize finish already, you don't really understand what's going on. It's hard for you to do the questions also. And then another thing is you don't start with the challenging ones. You'll be like super demoralized. You start with the easier ones first. You practice, and you know how to use all your formulas and everything, all your concepts. Then after that, you can do the challenging ones. Then another thing is math, right? You have to time yourself. Because a lot of people, they don't finish the paper and then they lose like all the extra marks they could have gotten. And then what if the question at the end is like the easiest one? So it's very, very important. You have to time yourself. And another thing is, if you can't do the question, just skip. But don't skip everything. Just skip like a few. Okay? And you have to be super consistent. Like practice like every week, at least. Okay. Then this is your milestones. Actually, you have like super little practices, you realize. There's 3 only. And then some of you don't even have like WA, mid-year exams. Let's say it's replaced by WA, right? Some of you, your WA already passed. Or yeah, so you only have like 2 exams left. You have 1 exam to practice and then 1 real one. So it's actually super little time. And they will test you the entire syllabus from your Sec 3 to Sec 4. So you have like few months, you have to remember all